Hello students, in the previous lecture I discussed the stability of structures. Now in today's video I am going to discuss stability of certain structures which are shown on the whiteboard. Now there are 8 number of structures which I have shown over there, and I am going to discuss the stability of each and every structure one after another. Let us consider the first structure. Now you can see that it is a structure in which rigid joints are there, and it is supported on two supports, both are hinged, and it is asked to discuss the stability of following structure. So it is the first structure. Now in the previous lecture we have discussed about the stability. Stability is of two types. One is external stability and second is internal stability, and we will have to ensure that the structure is externally stable as well as it is internally stable also, and which should be overall stable. So here I am going to discuss the external stability as well as the internal stability. Now for external stability of any structure, the two conditions which are necessary are: first, the number of reactions should not be less than 3. So minimum number of reactions is 3. So let us check how many reactions are there. Now there are two hinge supports, so two reaction components over here, two reaction components over here. So R is equal to 4, which is greater than 3, and which is means the number of reaction components are more than 3. So the first condition is getting served. Now second condition which is necessary is that the reaction components should not be parallel to one another, and they should not be concurrent. So this condition also gets served because there are two vertical components, there are two horizontal components, and it means that the forces, that is reactions, are non-concurrent, and that is why it is externally stable. Now it is a rigid jointed frame, and rigid jointed frame is always internally stable, but here what is different is that there is a loop inside it, so it is not an open configuration. So it is a stable structure internally also, but statically indeterminate internally. So overall stability for this structure is overall stable. That is the answer. Now second, here right angle frame is shown over there, which is supported by means of a hinge and a roller support, and it is asked to discuss the stability of this frame. Now again we are going to approach in the similar manner. We are going to check the number of external reaction components. So external reaction components, 2 at the hinge support, 1 at the roller support, so it makes 3. But again we can see that 2 reaction components over here are acting like this. So this is the first reaction components, which is vertical component. This is the horizontal reaction component at support A, and the reaction at B will be acting like this. So if I extend it in this manner, we can see that all the reaction components are meeting in a point. So reactions are concurrent over here. So it means if any moment or couple is applied at A, the frame will suffer a rotation, and that is why it is an unstable type of structure. So it is, the correct answer is unstable. It is not stable, it is unstable. Now it is the third one, in which a beam is shown and there are two internal hinges over there. Again the number of external reaction components is equal to 6 over here, because there are two fixed supports. So 3 plus 3, that is 6. So 6 number of reaction components which may happen or which may take place over there, which is greater than 3. So first condition is getting served. Now second condition is that the reaction components should not be parallel and they should not be concurrent. So this condition also gets served, and that is why this is externally stable and it is internally stable already. Now the question number 4, in which again a frame is shown, which is a hybrid type of structure. Two joints are rigid joints and there are some internal hinges which are provided over there. Now if we go for external stability, there are 6 reaction components, so which is greater than 3, and that is why it is externally stable. But for internal stability, again if internal or if hinges are there, the hinges, there should not be 3 or more than 3 hinges along the same straight line. So no 3 collinear hinges. because 3 collinear hinges result in a mechanism. So, mechanism will get formed and it will be an unstable combination of hinges. So, the structure is unstable over here because 3 hinges are provided along the same straight line. 3 collinear hinges results in mechanism. Now, question number 5 over here. It is a rigid frame again, external stability, 3 reaction components. So, it is okay. The reaction components are non-concurrent, they are non-parallel. So, it is externally stable and it is internally stable also. The only thing is that this is internally stable but is statically indeterminate internally. So, overall stability is stable. Question number 6. A right angled rigid frame is shown over there and there are 2 supports, one is hinged, another is roller. So, 3 reaction components. So, minimum number of reaction components required is 3. So, here 3 reaction components are there. So, the first condition is getting served. Second, the reaction components should not be parallel, they should not be concurrent. It is also getting served. So, externally stable and it forms an open configuration. So, rigid jointed structure with open configuration, it is a stable structure and it is internally statically determinate also. Now, this one, question number 7. There are, it is a hinge or the supports are hinge support and one more internal hinge is provided over there. So, there are 3 hinges in a straight line. So, 3 hinges along the straight line or 3 collinear hinges result in a mechanism. So, it is an unstable structure. This one, the last one, it is a structure in which one joint is rigid joint and there are some internal hinges provided over there. Now, if we check the external stability, there are 6 number of external reaction components which is greater than 3. So, these reaction components are non-parallel, they are non-concurrent and that is why externally stable. Now, for internal stability, the hinges are there but hinges are not along the same straight line. There are only 2 hinges along the same straight line. So, no 3 collinear hinges. So, mechanism is not getting formed. So, it is again a stable structure. This is how you can discuss the stability of a structure. Thanks.